A function is a relationship between two quantities. Often we use variables to represent those quantities and show the relationship as an equation or a graph. Here are two examples of functions, y equals 2x minus 4 and y equals x squared minus 4x plus 1. We also have the graphs that go with them. The first equation represents a line when we graph it, the second one a parabola when we graph it. You've probably worked with these types of relationships in past classes. You may not have described them as functions though. This term we're going to be very concerned with identifying functions and using appropriate notation with a function. A function is a very specific type of relationship. Not all equations or graphs are functions. A function is a relationship between two variables in which each input value, often represented by x, corresponds to exactly one output value, often called y. So the idea is that an x is going to go to a single y, only one y value. If something is not a function, a single x value could go to two y values. I'll just call it y1 and y2. So this would not be a function if your x value could correspond to two different y values. Since not all graphs or equations are functions, it's important to be able to tell when you're going to have one and when you won't. So using the definition, remember that each x value for a function will correspond to exactly one y value. Let's think about what that's like on a graph. So x values on a graph relate to the x-axis, which is the horizontal axis. So for instance, if I were looking at an x value of 3, we look for 3 on the x-axis. And then x is 3 not just on the x-axis, but everywhere up and down on the 2D surface. So we have an x value of 3 all the way up and down from 3 on the x-axis. In fact, this vertical line is called x equals 3 because x is 3 everywhere on that vertical line. Now to be a function, you must only touch the graph in one spot on that vertical line because that would represent a y value. So here we have an x value of 3 corresponding to a y value of 2. 3 corresponding to 2. 3 does not correspond to any other value because that vertical line does not touch anywhere else. We can do something similar with any other x value. Think about a vertical line running through any other x value here. And what we see is each time, every vertical line will only touch the graph in one spot. That means for every x value, we have a single y value. This is what we call the vertical line test for a function. Basically, a single vertical line can only touch the graph in one spot for it to be a function. If it touches in any more than one spot, then it is not a function. So let's use the vertical line test on these next two graphs. The middle graph is a parabola. As we pass a vertical line through anywhere on this graph, we are only going to touch it once. So this is a function, just like the last example was a function. I should have labeled it as such. So the first two graphs are functions. The next graph, however, the circle, would not be a function because as soon as you take a vertical line, for instance, through x equals 1, what you have is that the graph is going to be hit by that vertical line in two places. So at x equals 1, we have two y values. This disobeys the function rule that you have to have exactly one y value for each x value. As soon as we have a disobeying of the rule with a vertical line, then we have something that is not a function. So a circle, a very common figure, is not a function.